In this video, we're going to talk about anti-aromatic compounds, and we're going to define what anti-aromatic compounds are. So cyclobutadiene, shown here, is unusually unstable. And we see that in the fact that the bonds of cyclobutadiene are not in fact equal like they are in benzene. If you recall, with benzene, every carbon-carbon bond is the same length. In cyclobutadiene, you can see that one bonder is longer here, or single bond-like, and the other bond is shorter, or more double bond-like. And interestingly, we can't actually draw resonance structures because of the differing bond lengths. So cyclobutadiene does not in fact have a resonance structure like the one shown here. Cyclobutadiene is an example of an anti-aromatic compound. Now remember, when we defined aromaticity, we defined aromatic compounds as unusually stable compounds that also have cyclic pi systems. So anti-aromatic compounds are unusually unstable compounds with cyclic pi systems. If we're going to look at any other types of compounds, we would classify those as non-aromatic. So our anti-aromatic compounds then are going to be, we have a system that we can determine if something is anti-aromatic that is very similar to the system that we used for aromatic compounds. Let's look now at the anti-aromatic compounds in terms of stability. And this arrow you can see here showing the increasing stability indicates that the aromatic compounds are much more stable than your anti-aromatic compounds. Your anti-aromatic compounds are over here on the end, and in fact they're less stable than any types of cyclic compounds with localized electrons. So anti-aromatic compounds are very unstable in terms of things, in the grand scheme of things. Now anti-aromatic compounds, as I mentioned, are going to have, we can determine those by looking to see if we are cyclic, the electrons are completely delocalized, and they are planar. And those three rules are the same rules that we would go through when we were determining if something is aromatic. The difference here, the key difference here, is number 4. And for anti-aromatic compounds, they will have an even number of electron pairs. An odd number of electron pairs, recall, would be an aromatic system. So for anti-aromatic compounds, we're going to be looking for even numbers. And so that is the case if we go back to cyclobutadiene. You can see that they have 2 electron pairs, which corresponds with an even number. And so that is an anti-aromatic compound.